We are going to examine a pretty complicated circuit. So we're going to start off with a battery that is in series with a resistor. We're going to have another resistor over here that is on a branch, on a parallel branch. Here's another battery and a third resistor. And these things, let's call this R1. R1 is 2 ohms. R2 over here is 4 ohms. And R3 in the middle is 1 ohm. 1 ohm. This battery, we'll call E1, is 6 volts. And this battery, E2, is 9 volts. And we're going to try and find I3, which is equal to the current through the 1 ohm resistor. And so in order to do this, we're going to first label our currents and loops. And so let's pick, and you don't have to, but I like picking the batteries as a place to start my loop. So here's one loop. We're going to go counterclockwise through here. And let's go clockwise around this loop. So we'll call this loop 1 and this loop 2, just for bookkeeping. And I also like to usually visualize the currents as flowing out of the positive terminal. So we'll call this I1. We'll call this I2, and that actually sets up the direction for I3, because if both I1 and I2 are entering this node, then I3 has to be leaving. So I3 is going to go up this way and up through here, and it'll enter here and then at this node, and then I1 leaves to the left, I2 leaves to the right. And so that tells us the following, right? So the current going into this node up here is I3, and I1 and I2 are leaving. So that's going to be, we'll call this equation 1 for bookkeeping. Now let's go around loop 1. So loop 1, we're leaving the battery, and we're heading in the positive, from negative to positive, so we're going to have a plus E1. We're going to cross R1 in the same direction as the current, so minus I1 R1. And then we are going to cross R3 in the same direction as the current, so minus I3 R3 to get back to our battery, so that's 0. Loop 2, we're going to start with the battery. In this case, it's E2. We cross R2 in the same direction as the current, so it's a minus I2 R2, and then a minus I3 R3. That's equal to 0. And so this is equation 2 and equation 3. And now we need to use all three of these to solve for our unknowns, which are going to be I1, I2, and the thing that we want, which is I3. So we want to eliminate these first two and end up making a equation, a linear combination of those that only has I3 in it. And so there are lots of ways to do this. What I'm going to do in this example is get an expression for I1 as a function of I3 from this equation. We'll get I2 as a function of I3 from equation 3. And then we're going to take those two and put it up into equation 1, and then we'll have just something with I3 in it. Okay, so let's start with loop 1. I'm going to rewrite it just so we have it. Loop 1 said that we have the following. I1 R1 minus I3 R3 equal to 0. Let's solve this for I1. And so this becomes I1 R1 is equal to the terms that are left over. And so I1 is our battery minus our unknown over R1. Okay, so this is something that we're going to use. Loop 2 looks very familiar, very similar. So we'll do loop 2 over here while we have some space. And you want to remember to always use all three equations. If you don't, then you're going to end up getting things like I1 equals I1, and it's not really going to help you. So let's solve this for I2. And now we just need to divide by R2, divide both sides by R2 to get I2 by itself. Okay, so the first equation that we had was that I3 is equal to the sum of I1 plus I2. And so that is going to look like E1 minus I3 R3 over R1 plus E2 minus I3 R3 over R2. And now we have an equation that just has I3s in it. So let's solve this thing. It's going to take a little bit of algebra, but the first thing you want to do is get a common denominator. And so I3, let's give ourselves plenty of room to work here. It's going to be R2 times E1 minus I3 R3 plus R1 times E2 minus I3 R3. The whole thing over our common denominator, R1, R2. You can see the R2 would cancel over here, which gives us this first term. R1s would cancel to give us our second term there. Okay, so now we want to solve this expression for I3. And again, it's just kind of a lot of algebra at this point, but let's start working our way through it. So we have I3, R1, R2. I'm going to bring the common denominator over. And we can also evaluate the terms that we had up top. So this is E2, R2 minus I3, R2, R3 plus E2, R1 minus I3, R1, R3. And this is not a 2, that is a 1. That is a 1. Okay, so now let's get all the I3s over on one side. This is R1, R2 plus R2, R3 plus R1, R3. And that's equal to E1, R2 plus E2, R1. There's some beautiful symmetry in this problem here. And we're going to see some more in just a second. So I3 is going to be E1, R2 plus E2, R1 all over this big product of resistances. R2, R3 plus R1, R3. And if you look here, we have a voltage times a resistance over resistance squared. So 1 power of resistance is going to go away. We're left with volts over resistance, which is the correct unit. So we're on the right track here. And so let's plug things in now. This was 6 volts times 4 ohms plus 9 volts times R1, which was 2 ohms, and one that was all the way on the left, and our big product down on the bottom, which is 2 ohms times 4 ohms plus 4 ohms times 1 ohm plus 2 ohm times 1 ohm. Okay. And so this looks like 24 volt ohms plus 18 volt ohms over 8 square ohms, which is a weird unit. 4 square ohms is 2 square ohms. 24 plus 18 is 42 volt ohms. 8 plus 6 is 14 square ohms. One of these is going to cancel. And 42 divided by 14 gives me 3 volts per ohm, which is the same as 3 amps. Now, one of the things that you can do, and I would encourage you to do this, is to go back and check that you did all of your work correctly, right? So we know I3 is equal to 3 amps. And we knew that I1 was equal to E1 minus R3 over R1. Well, that was 6. I'm just dropping units here now. For clarity, 6 times 3 times 1 over 2. So 6 minus 3 is 3. 3 over 2. So it's 1.5 amps. And if we did this right, I2 would better end up being 1.5 amps as well, because the sum of these two has to equal I3. And so this was E2 minus I3 R3 over R2, which is going to be 9 minus 3. It's the same combination as up here, divided by 4, which is 6 divided by 4, which is the same as 3 divided by 2, which is 1.5 amps. My computer's running a little slow there, but you can see that 1.5 plus 1.5 is 3. So we get our check.